In UniFi's zone-based firewall setting, when you want to introduce a new VLAN to define the firewall rules, you have two options. You either create a dedicated zone for it or customize your existing zone by adding extra policies. So this is the part 2 of this topic. We are going to focus on the second option, which is you don't create any new zone. You simply enhance your existing zone's policies. You must be very familiar with the old way for UniFi network controller to configure firewall. In the left side, I show you a UniFi gateway which doesn't support the zone-based firewall yet. And in the right side, I show you the new zone-based firewall. In the old way, when you create a firewall rule, this is the screen you see. And in the right side, you see the new way to create a rule, or Ubiquiti call it policy in the zone-based firewall. On one hand, the new way does have some new features. On the other hand, as I already discussed in my previous video about iptable filters, they work in the exact same way from backend perspective. So let's first briefly go through what are new in the new policy. If we compare the left and right side by side, for the old rule, you have to specify a type. The type is crucial for the backend to determine two things. First, what's the network interface the rule will apply to. Second, where the filter will be put in the iptables. Because in iptables, there are three main branches: in, out, and forward. Your setting here will determine that iptable filter flow. In the right side, instead of specifying a type, you need to specify the zone. The zone internally will decide the original what's decided by the type. So from technical perspective, it's the same thing. It's just on UI, you do the same thing in slightly different way. Then the name is the same. Action is the same, three options. For protocol, here for the old way, you have this option. You can say before the predefined or not. But in the new way, see, this is the protocol setting. You don't have that option. The system always put your custom policies before the predefined. Then here comes the source and the destination, right? In the old way, for source type, you have three options: object, network, IP address. But see, the new way, it has much more new options. You can say device, basically it's based on MAC address, or network, or IP address, or MAC address. And then you have another two options. You can match opposite or match MAC address within a network. Apparently in the new way, it has more options. And for destination zone, here you can even specify app, domain, region, which are only available in the simple rule, which is traffic rule in the old way. Now it's integrated to the firewall policy. In the old way, you have a way to specify address group. In the new way, you have the same feature, but it's hidden under IP object. Then you can pick the old address group. For port, the setting is similar, and the MAC address the same. Then when it comes to advanced setting in the old way, see here, you can match the state, which is the backend Linux connection tracking states. In the new way, see, it supports some more user-friendly setting. For example, for this so-called return traffic, in the old way, it's simply established plus related. But because these two things are often used together, so in the new way, it's bonded together as a dedicated option. But it's the same thing. And in the new way, you can also go back to your familiar old way to specify these four different states separately. Then for match IPsec, it's the same thing. And for logging, it's the same setting, just in the new way, it's renamed as syslog logging. Another big improvement in the new way is about schedule. You can enforce the policy based on whatever schedule you want. In the old way, you cannot do that. You can only do scheduling if you specify the so-called simple rule, which is traffic rule. For this simple rule, yes, you have scheduling feature, but not for the advanced firewall rule. Okay, So this is just some brief going through about the changes in the new policy setting. Even from the UI perspective, they are almost the same, right? And from backend, as I already mentioned, they work in the exact same way. In UniFi Network Controller, in Settings, Security, you can see the 6 built-in zones. And in the left side slice, you can see I want to introduce 4 new VLANs for admin, IoT, UniFi Protect cameras, and non-UniFi cameras. In the previous part 1 video, I achieved this by introducing 4 new zones, which end up with 64 new cells in the zone matrix to be taken care of. It's a very tedious process to make sure all the new cells are configured properly. In this video, let's explore another way. In the network setting, you can see I have the 4 VLANs created from VLAN 40 to VLAN 70. By default, in the security setting, for any new VLANs you create, they will be automatically added to the internal zone. Internal is just a new name. We are all familiar with another name for it, which is LAN. So we are ready to start our configuration. Whenever you try to enhance the existing policies for a given zone, especially for the internal zone, don't rush into it. My suggestion is the very first new policy you may want to introduce is the block inter-VLAN policy. Blocking all as the very last effective firewall rule is a best practice because it may save you a lot of potential future headaches if you secure your zone in that seemingly extremely cautious way. By default, you don't want to enable any inter-VLAN traffic. So let me do that first. Because all of my new VLANs are in internal zone, I need to go to this particular cell from internal to internal. Click on it. The default rule is allow all traffic. And you can see the lock icon here, so I cannot do anything about it. To overwrite it, I have to create a new policy. Block inter VLAN. Then the source and the destination are both internal. I'm good. And it's any to any. I'm good. I don't need to change anything. The default action block is also good. Add policy. The block inter-VLAN traffic policy is the simplest policy you can create. You just give it a name. That's it. And you can see it's automatically put ahead of the existing one, which means it will be executed first. So the system will block inter-VLAN first before allowing all traffic. Okay, we can simply validate it. For example, from the admin VLAN, let me try to ping IoT. In real world, I should be able to ping IoT from admin, right? But simply because of this new block inter-VLAN rule, let's see whether it's possible now. See, it's not possible. And from regular to protect, yeah, also not possible. Apparently, this block inter-VLAN brutal rule is working now. But by adding this rule for this particular default zone, it only achieved this particular red link. Because now from default to admin, we can validate in the terminal, ping the admin machine. No, it's not pingable, right? So we are good with this red one. But for all this IoT, unsafe, protect, they are not working now. So we need to enable them to make them green, right? And because all the VLANs, they are part of the internal zone. Our change will be focusing on this particular cell from internal to internal. So let me start from the IoT green link. Click on internal to internal. Click on create policy. Name it as allow default to IoT. And for source zone internal, but this time I only want to choose default network. So I need to specify it here as a network. Then for part, I'm okay with any. For action, this time it should be allow. The auto allow return traffic is automatically selected, which means the system will automatically add another rule for another direction from IoT to default. You will see that later. Now we are in the destination zone setting. So I'm good with internal, but I need to specify the destination network, which is IoT, right? IoT is VLAN 50. Then I'm good with all other settings. Let me add policy and see, we only want to create one new policy, right? But see the end result, the system created two. This one showing the brick wall icon is the one we created, but the system automatically added this one showing the lock icon. It has the same name, but with a additional text. It says return. If we look at this automatically added new one, you can see the system automatically add a new one from IoT to default network, and it will allow the return traffic. If you are familiar with the backend Linux iptables, the so-called return traffic simply means the connection tracking state is related or established. We are not done about this policy yet. See what's wrong with these four policies? They are in wrong sequence because the system doesn't know what's your intention. The system may put your new policies in a position which does not meet your need. For example, this time, the system put my new rule after the block inter VLAN. Of course, it won't work, right? So I need to put the new rule ahead of the block inter VLAN. How I can do that? There's a link here. It's called reorder. Then you can drag and drop. So let me drag the block inter VLAN to make sure it is the very last effective one. By the way, you cannot drop it after this allow all, so you have to drop it here, but it doesn't matter. If we do this, the very last internal allow all traffic will never be executed. Okay, so we are good, done. Now let's validate it. From the default network terminal, let me ping the IoT device. See, it's pingable thanks to the new policy we created. We have taken care of this IoT link, but we still have the other two inter-VLAN links for protect and for unsafe. Let's work on them. Go to the from internal to internal cell. Of course, you can add two new policies, one for protect, one for unsafe, right? But there's better way to do that. Let me click on the newly created one from default to IoT. Remember, for the destination zone, for network, we selected VLAN 50 because it's for IoT, right? You can see here, you can do multiple selection. So for our case, let me simply select VLAN 60 and 70 as well for protect and unsafe. That's it. We can use one single policy to take care of multiple destination VLANs. Then, of course, now the name is not proper. Let me modify it. Let me say to IoT, protect, and unsafe. Okay, I don't need to change anything else. Apply changes. Let's quickly validate it. From default network, if I ping the protect device, it's pingable, so it works. Then move on. About this particular one, from default to external. In fact, we don't need to do anything. Default is part of internal. External is showing here. Basically, we are talking about this cell, right? If you click on it, you can see the default policies already work for us. It's already enabled. Default network is able to access internet. I don't think I need to waste your time to show you this. You know that. Then for this particular one, the allow all for default to default, we are talking about this particular cell. But for this case, these firewall rules don't matter at all because we are talking about one single VLAN, the default network, the VLAN 1 to itself. For this type of traffic, it won't go through router. So the firewall rules don't matter in this case. So we are good with all the red and the green links for this default network. Okay, let's move on. For admin network, of course, we want to give it wide open access to anything. So you can see all the arrows, they are green. To configure this VLAN, you may hate our initial block inter VLAN policy because we have to enable all the links, otherwise they will be blocked by our policy, right? So let's do that. All the VLANs, they are part of the internal zone. We are again talking about this one single cell from internal to internal. Click on it. Then let me create a new policy. Based on our previous experience when configuring the default network, we know we can choose multiple destination VLANs in one single policy, right? So this time, let me name the new policy as allow admin to all VLANs. Then for source zone, it's internal, of course, but network, I need to select admin, which is VLAN 40. Then for destination, I need to select other VLANs all the way from VLAN 40 to VLAN 70. By the way, here I choose VLAN 40 or not, it doesn't matter because it won't be effective. It's the same admin VLAN, right? Save it. And then, of course, for the action, it should be allow. By default, this auto allow return traffic is selected, so the system will automatically create a separate policy to enable the return traffic from all the destination VLANs. Okay, we are good. Add entry. So let's see what happened. This time, the allow admin to all policy is inserted to the correct place, so we don't need to modify the sequence. You can see the automatically generated allow return traffic, right? And then the very last rule is still the block inter VLAN. So we are good. Oh, sorry, I just realized I forgot to select the default network. Let me modify this policy. So for destination zone, I need to select default as well. Okay, just by adding this single new policy, we enabled 1, 2, 3, 4 destination VLANs, right? And for the same reason, for this from admin to admin, we don't need to do anything. From admin to internet, we don't need to do anything, right? We are not done yet, because in this diagram, I only show you the new VLANs I want to support and the internet, right? But remember, in the default matrix, we have other built-in zones. For example, VPN, DMZ, right? But for this particular case, for admin, even for our previous default, we don't want to mess up this 3 green allow all because they work for default and admin VLANs. That's why we are good for now for admin VLAN about these 3 built-in zones. Let's move on. So the next one, IoT. For this particular VLAN, you may appreciate our previous block inter VLAN policy. Because of that one, we don't need to do anything. Almost. We already support 1, 2, 3, 4 red arrows because of the block inter VLAN policy. We can validate that. So from IoT, let me ping admin, not pingable, ping default, not pingable. That's understandable. However, what about this particular one? From IoT to IoT. So if we check this matrix from internal to internal, for all the existing policies we have here, it seems from IoT to IoT will be blocked due to this block inter VLAN policy, right? Because for this policy, we say from any to any, it should be blocked, right? But is that really the case? In the rightmost terminal, let me show the IP address. You can see it's in subnet 50, which means it's a IoT device. Okay, then let me ping the third terminal, which is another IoT device from this terminal. See, it is still pingable, which means this block inter VLAN policy is not effective to IoT to IoT. Why is that? Very simple, because we are talking about one single VLAN, VLAN 50. For the same VLAN traffic, it simply won't go through the router. So the firewall policies, they don't matter at all to this type of traffic. If you watched my previous video, the part 1, you know to achieve this red block, it's very simple. We go to network setting, under switch isolation setting, for device isolation ACL, we simply choose IoT VLAN, VLAN 50. That's it. We want to create a new ACL rule in each unified switch so that the same VLAN traffic for VLAN 50 will be handled by the switch. It will be blocked by the ACL rule. So let me apply changes. Then go back to the rightmost terminal. Let me ping the same IP address again. See, this time it's not pingable because of our new ACL rule. So we are good. By the way, this VLAN level device isolation is very brutal. It's more about those suspicious IoT devices. If your device has legitimate reason to communicate with each other in the same VLAN, you may want to check out the later part when I talk about unsafe network, how you can enable the communications between specific devices. We are done about this IoT VLAN. Now you may start appreciating our block inter VLAN policy. So because of that, for this type of dangerous VLAN for IoT, even if we forget something, we may not cause serious issue because by default, the traffic will be blocked. Okay, move on to a VLAN for UniFi Protect devices. By the way, for UniFi Protect cameras, they don't really need internet access. Even if you want to upgrade the firmware for your camera, it can be done by your cloud key or by your gateway. The camera itself doesn't really need internet access. But just to make this VLAN different than my next one, the unsafe VLAN, I purposely want to enable this internet access. In fact, you can think of it another way. Instead of calling it Protect VLAN, you may think of it as a, let's say, party VLAN. So all your party participants, they can access internet, they can communicate with each other, but they cannot access your own personal VLANs. Having said that, let's see how we can configure this one. Again, thanks to the block inter VLAN rule, we don't really need to do a lot because the only difference for this VLAN, if you compare to previous one, is this green one. Right? But we all know by default from the same VLAN to the same VLAN, we don't need to do anything. The Protect VLAN is the easiest VLAN so far because literally we don't need to do anything. We already achieve all the red, green links by default. If you don't believe it, we can simply test it. So from the Protect terminal, let me ping internet. Okay, pingable, ping default network, not pingable, ping admin, not pingable, ping unsafe, not pingable. Then let's use the rightmost terminal. Let me show you the current IP address. It's in VLAN 60 in Protect network. So then let me ping the left side Protect device. Yeah, it's pingable. It works out of box. Okay, then let's move on to the very last one. Because it's a unsafe network, it's different compared with previous Protect VLAN in two places. First, I don't want it to have internet access. Secondly, I don't want it to access another device in the same VLAN. So then let's see how we can achieve this block all policy for internet. Go to security setting. From internal to external, I need to create a new policy. Name it as block unsafe to external. Then the source zone is internal, but for network, I need to limit it to VLAN 70, which is for unsafe VLAN. Then the action is block. The destination zone is internet. Okay, I'm good. Apply changes. The new policy is correctly put at the very first step. So we are good with the sequence. Now let me validate. From the unsafe terminal, let me ping internet. Yep, it's not pingable. Good. Then for this particular one, block all for the traffic inside this unsafe VLAN. In the same way, we need to go to networks for the switch isolation. For device isolation ACL, let me edit it, then add VLAN 70. Save. Okay. Then in the rightmost terminal, the current address is in VLAN 70. It is a unsafe device. Then let me ping the left side another unsafe device. Okay, it's not pingable. So we successfully achieved this particular red link. In fact, this is the exact same scenario in my part 1 video. However, after that video, I received several comments regarding the incompleteness of this scenario because the unsafe cameras, they don't have access to anything else, which means there will be trouble for them to connect to NVR, right? The reason I didn't mention the NVR in my part 1 video was I wanted to simplify the scenario, focusing on the zone-based firewall. But if the fact of missing NVR confused a lot of people, let me mention that in this part 2 video anyway. So here is a common scenario. You have multiple unsafe cameras, but anyway you need to record a video somewhere, right? So let's assume you have an NVR. Depending on where the NVR is, you may need different ways to secure the access. If it's part of another VLAN, not the unsafe VLAN, then of course you have the firewall to help you, right? But in this video, let's talk about what if the NVR is within the same unsafe VLAN, how you can enable this green access. Remember, we already enabled the device isolation for VLAN 70. So in the lower part of the screen, I have 2 unsafe cameras and a NVR. Then from the unsafe camera 2, if I ping the NVR, yeah, it's not pingable as expected, right? But it won't work in real world because the camera need to access the NVR. How you can even enable this access? Remember, they are in the same VLAN. That means you cannot rely on firewall, right? And for the switch isolation setting is on the VLAN level. You cannot choose a particular machine, right? It's not a problem because there's another place to create ACL. So if you go to security, see there's a ACL tab, and we need to create a MAC ACL. The ACL is directional. For this scenario, we need to enable the access for both directions, which means we need to have 2 MAC ACL rules. So let me create the first one. Allow unsafe cameras to NVR. Then the action is allow all switches for VLAN. Let me select VLAN 70 for source because it's from unsafe cameras. I simply want to select any because I want to give all unsafe cameras access to NVR. For destination, this time I need to select a very particular destination, which is the NVR device. Here, the system lists out all the MAC addresses. In the NVR machine, I can show the IP link. Then here, I can easily find out the MAC address, which is this one in the UniFi network controller. Let me select it, save, then add rule. Remember, we need to add 2 rules, right, for both directions. So let me create another entry. This one, allow NVR to unsafe cameras. Allow. The VLAN is the same VLAN 70. For source, it should be device. Let me select the device. This is the NVR. Then for destination, I simply say any. Add rule. Okay. In the unsafe camera 2 terminal, you can see the ping is still going on, right? Once our ACL rule is active, I expect this ongoing ping to be successful. Yes, you see the effect. Automatically, the ping is successful. This proves from the unsafe camera 2, it can access NVR. Stop it. If I show the IP address for the unsafe camera 2, we have this IP address, right? Let's make sure from NVR we can access it. Yes, we can. Okay. Remember, we only want to enable the access from cameras to or from NVR, right? Between 2 different cameras, I still want to block their access. So is that still true? After we add these 2 new ACL rules, we can validate it. From the unsafe camera 1, let me ping the unsafe camera 2. Yeah, it's not pingable. So we are still good, right? At this point, you may think we are done for this video, right? No, hold your thought. Let's revisit the matrix. All of our new VLANs are inside the internal zone, right? So basically, we simply want to focus on this particular line in the matrix. We already touched this particular cell from internal to internal and from internal to external, right? But we have never touched these 3 originally green cells. Do you notice anything wrong? Yes. For the 3 dangerous VLANs, IoT, protect, and unsafe VLANs, if we don't change these 3 cells, they will have unlimited access to VPN, to guest, and to DMZ. apparently that's what you want to avoid, right? So we are not done yet. Let's continue changing these 3 cells to make the VLANs work. Let me start from this one, internal to VPN. Click on it. So the default is allow all. We need to create a policy. We want to say block IoT, protect, unsafe to VPN. Then for source zone, I need to customize the network. Select VLAN for IoT, VLAN 60 for protect, VLAN 70 for unsafe. Save it. Then I want to block the access. Then for destination zone, it's VPN, right? Apply policy. We are done with this cell. Then in the same way, let me quickly move on to the hotspot and the DMZ to make similar changes. Now you may think we are really done now, right? Not really. See, we simply completed the row level. But see this column? It is for internal as destination. So we are not done yet because this column is also relevant to our 4 new VLANs. If I click on from VPN to internal, you can see by default it's already allow all. You may think, what's wrong with it? From VPN, I do want to access all the 4 new VLANs. Then this firewall rule does work, right? Not really, because if you check the other direction, from internal to VPN, here we already say block the 3 new VLANs access to VPN. Right? Which means, for example, from the unsafe network, yes, it cannot initiate the communication with VPN, right? That's what we want. But from VPN, we do want to be able to connect to unsafe network, because from VPN, we may want to check the status of the unsafe cameras, right? But because of this block policy, the traffic won't be possible when it returns from the unsafe network. So we still need to do something for this particular cell from VPN to internal. So let's create a policy. Let's say allow VPN to IoT, protect, unsafe. Here, I don't want to select admin. That's my choice. Then I want to say allow. See, this checkbox, that's the crucial thing for this step. It will automatically create a allow policy in the other direction. So we will check it later. For destination, let me choose network. I only want to select VLAN 50, 60, 70 for IoT, protect, and unsafe. Save it, add rule. Okay, I'm good about this direction from VPN to internal. So let me check the other direction from internal to VPN. See, a new policy is automatically inserted here. This is the effect of the policy we just created in the other direction. See here, the source is the other 3 VLANs and the destination is VPN. So basically, this policy will allow the return traffic from the 3 VLANs to VPN, right? But there's a problem. This particular policy is in the wrong order. See, the first policy is block all. Even without executing the second one, the first one already returned and block all. So we need to change the order. Let me do that. Okay, done. It will first allow the return traffic and then block all. So in this way, we enabled the access from VPN to those 3 VLANs. Of course, there's another way to do this. For example, what I did was I go to VPN to internal. I created this allow policy, right? Instead of doing this, you can directly go to the internal to VPN and manually create a policy to allow the return traffic. It also work, right? And there's another thing, I won't do it in this video, but you need to be aware of that, which is from VPN to internal. See, what we are saying basically here is allow everything. But in real world, you may want to block the access from VPN to admin. It's your choice. You may want to do that, okay? So in the same way, let me check from hotspot to internal. You see by default, it's already very secured because it's gas network, right? So by default, it's already block all. So I don't want to change it. Then for DMZ, see by default, it's block all and it only allow return traffic. I don't need to change this one. Okay, so I'm good about this column. At the very end of the video, let's talk about the gateway access. You may notice I never touch the gateway just to simplify this video. I don't want to add more complexities. But in your situation, you may want to add some new policies regarding gateway. For example, from your unsafe network, you may not want unlimited access from your unsafe cameras to your gateway. You may want to limit the port, for example, right? But that's really case by case. Different people has different requirements. That's just something you need to pay attention for your own network. The last thing is about internet access. In my example about the unsafe VLAN, I brutally denied all the access, including internet. But in your case, you may want to open up some specific services to internet. For example, network time protocol. But again, that's case by case. You need to deal with that in your setup. Okay, so now let's summarize. If you watched both the part 1 and this part 2, I'm not sure what's your feeling about the two different approaches. In the new zone approach, the benefit is dozens of new cells created for you. For each cell, the scope is only about that particular from and to. No matter how badly you mess up with the settings for that cell, it won't impact other cells. That's a great benefit by using the matrix to do the customizing cell by cell. But the apparent downside is it's too much. It's a too tedious task to customize so many cells. That's about the part 1, about the new zone approach. And for the new policy approach, we talk about in this particular video, you may notice most of the work was about this particular cell from internal to internal, right? So when you are focusing on this particular cell, you may notice what we had been doing was very similar to the old way when you set up firewall rules. Basically, you are doing the exact same things in the old way. It's just the scope is only from internal to internal, right? That's either good or bad because some purists for zone-based firewall may not like it because you give too many flexibilities within one cell. You may mess it up. But someone else may argue about the same flexibility thing because that might be the exact benefit of using this approach, just customizing this particular cell. Just like in programming, you either write a very long, very safe code, it's not very performant, but it's less buggy, or you can write a very short, very efficient code. Of course, that piece of code may be very buggy and may produce errors down the road, right? But that's your choice. The system gives you the flexibility to do the same thing in two totally different ways. It's up to you about which one you prefer. And then when it comes to the approach in this video, we are not really 100% focusing on this cell. We also need to worry about this row and this column. So totally we need to worry about 11 cells. Even though much less than part 1, is still some work involved, right? That need to be considered as well. Okay, this is a super long video. Thanks for watching.